Thank you all for coming and welcome to this talk about Python tooling for continuous deployment. Thanks for all the organizing at PyParis 2018. Quick introduction. So who am I? I'm called Arthur Lutz. I work at this company called Logilab. You can find me on Twitter, but apparently we shouldn't be doing that anymore. So if you want to go onto Mastodon, onto the Fediverse, that's a way better option. A little bit about myself. I've been working quite a few years at Logilab. I'm also the organizer of the Python meetup in Nantes, also the meetup about SaltStack here in Paris, and other various things. What we're going to talk about here today is how we benefited from a rich Python ecosystem to move a couple of projects from a sprint-based approach of delivery to a continuous deployment approach. So the idea was that we had this kind of agile sprint type delivery where we would sprint for 1 week, 2 weeks, 3 weeks, deliver a bunch of features, bug fixes to production. And so we'll take a look at the various tools that, in Python that we benefited from to be able to transform this process into a continuous delivery process. The idea here is that it's not a project where we start from scratch as a continuous delivery. It's an existing project where there's also a kind of a change approach that had to be done with the developers, with the product owner, with the end users, etc., or with the people that tested the application. And so we wanted to give some feedback about that. A little bit about continuous delivery. So here's a diagram from Wikipedia. The idea behind continuous delivery is that we have this process where the delivery team is going to submit some changes to the product, and we have a number of steps that can enable this change of code to get to production or not. Here we see there's the, I don't know if you can see it in the back, there's a build and unit tests that will guarantee a certain quality to the changes that were submitted. Then we have the step where the automated acceptance tests are run. And we have also some user acceptance tests, and the idea is that it gets to a release. And so one of the key ideas to remember here is that what we're aiming for is to enable a flow of modifications to get to production. The idea is to avoid stacking up some features that aren't tested for a while, stacking up some features that the client asked for but maybe didn't really want or wanted in a different way. So getting it to an environment where the client can test it out as fast as we can enables us to iterate really quickly. Here's a preview of the Python stack that we're using for this. I'm going to go back into detail in some of the components here. Maybe you'll see that right from the start there's some components listed here that aren't in Python. It's actually because most of the time there's Python bindings that enable us to interact with some of these stacks. And we'll see how each component is used. The slides will be published, so don't worry about that. So one of the first things that we tackled was reproducible environments. So the idea is that we go from a situation where we have a documentation to install the software or the stack. And a situation where a developer will say, hey, it works on my laptop, but it doesn't work on production, or it doesn't work in someone else's environment. So we switched to Docker. We switched to Docker Compose so that we can set up a complex environment. This One of the two client projects is a complex application with a number of services running. The Docker Compose enables us to describe a service, and the service is customized through a Docker Compose override, which was then superseded by a environment. The new way of doing it was through a .env that describes the differences between the environments. And so the final idea is to have something which was reproducible, so the images are built only once, and they run in the different environments. So in acceptance, testing, pre-production, and production, we have exactly the same images, and they just vary according to these variables. One of the other things that you might notice here, we have a way of using Docker in development environments where we can use the volumes to have the equivalent of pip install-e, where you will say, oh, that part of the code is actually on my machine, and I want to interact directly with it and modify in my IDE instead of having it in the Docker. So one of the things that you need to do when you're shipping often is assure the quality of the code. So here we're going to start with, you have to test often, break it, test it again. So for that we use some very nice software in Python. So Tox is used for reproducible test environments. So all the dependencies, the Python dependencies which are required to run the tests, are described in a Tox file. That's kind of standard now on a lot of projects, and it's a very nice way to isolate these runners. We use PyTest, obviously, for the test runner. PyTest is really powerful. It has lots of extensions, fixtures, and whatnot. One of the fixtures that we use is PIFPath, which is a nice project as well, which enables you to launch some daemons in a temporary fashion. So you'll say, I want to do my unit tests with a real Postgres instead of trying to fit it into SQLite. And this will launch a Postgres as you run the test and then close it down at the end. We use some FLEC8 to check the quality of the code, and isort to sort the imports. Obviously, those tests can run on the developer side, but what's most important is they run in the continuous integration. So we have Jenkins that runs the continuous integration, and one of the Python tools that we used to pilot Jenkins was Jenkins Job Builder, which is a project initiated by the OpenStack project. What's nice about it is that it enabled us to kind of iterate over how we use the CI. So we had different phases, and so this dates back quite a while now, but we kind of started testing everything that would arrive in the draft-based commits. So we're using Mercurial, and so this was unstable. Then some of the Jenkins jobs were parametric, and then we decided just to test the public change sets and have user-centric CI, which was on the side. Component-centric was also introduced, and now we're kind of selling down onto the feature-centric CI. So what you might know in merge requests in GitHub and Travis and whatnot. So the idea is that when you push a certain feature, the test will run on this feature. So even if you have different commits, that semantic piece will be tested. And so now this is done on the project with having Fabricator and Jenkins talk to each other through this extension, which is called differential Jenkins jobs. The idea is that when we push a set of features to the review, as close as possible to the review, we'll have the results of the continuous integration that says this review that you're reading is okay. It can be merged on top of the public branch, and the tests run fine on it. We also switched to Jenkins files to have the definition of the CI job as close as possible to the code. So the CI runs all the time. What's important if you want to ship often is to have also some top-level tests. So here, exception tests are important. So we can break them often, and then deliver again and see that they pass. So BDD is behavior-driven development. I forgot what BDD was. Yeah, behavior-driven development. So the idea is that you interact with your client and with your users using some common ground language that is not a programming language. So for this, we use Behave and Robber, and we plug it into Selenium using the Python bindings for Selenium, which runs the test in a browser and gives you the result of what happens. Right now, on one of the projects, this is actually just checking that the views and what we display to the user really appears. We're going into the next phase where the actual exception test will modify things in the database because we're in separate environments. But for now, it's just checking in a type of read-only fashion. The other important thing, so we talked about Flake 8, which is not technically a testing, but it is more of a quality control approach to code. When we put that into the continuous integration with Jenkins, we can get some metrics out of that. So we'll have the number of tests that are run and the number of tests that are okay. We'll also enable a way of getting metrics. So if you use Pylint, for example, it will give you a grade or it will give you a coverage. So this is the first thing that we put in place, so we can measure the quality of the product over time. And so again, we have this process of where we enable the developers to push. This for now is a non-blocking step. We'll come back to that, but the idea in continuous deployment is that some of the steps are a blocking side, so we'll say we won't push this in production until the tests aren't green. For the quality side right now, it's an optional side, so we enable the integrators to integrate even if the score has gone down, but we have this kind of instant feedback that is enabled by these tools. So in Jenkins, we can configure these metrics to be collected. We also put in place the scanning of the code base using Sonar Python, which is a plugin for, which is one of the scanners in SonarQube. Again, SonarQube is not Python, but we have a way of working with Python code inside of that. And so we've seen this on other projects where it's actually something that stops the code from getting into production, where we can say SonarQube is actually a blocker, which says this won't go in. To work on the quality of the code, peer review is extremely important. We have a workflow using Mercurial. So Mercurial is a distributed version control system written in Python. That's one of the main reasons why we chose it. So we're not using Git. And with Mercurial, we have some interesting extensions such as Evolve, which is presented as we speak, I think, in another room. So with a notion of public and draft change sets. And for that, we have an extension that in Mercurial that enables us to take a pile of changes in Mercurial and send them to Fabricator, where we have the review going on. So now onto the shipping. So to ship often, what we use is we use Rundeck. So again, not Python, but we have some Python bindings to be able to extract or to define jobs inside of Rundeck. Rundeck is interesting because it's a shared kind of administration of the shipping, where the logs are shared. We can have a URL that is easily that you can send to a colleague saying, "Oh, this is working. This is not working. Can you take a look at that?" We have pieces of software that generate the version information. So we go from a semantic versioning where we say every sprint we bump up the version. Here we have versions that are daily. So every day there's a generated version. So that was one of the technical challenges for this. And whenever we ship a bundle, so in continuous delivery, we have two models mainly, I think. One of the models is the train leaves every day at the same time, and we put a bunch of features on it, and we can manually send a new train. And the other one is every time we integrate a change, it's shipped to production. Here we're using the train model, so every morning the product is shipped, and we can ship it manually by going into Rundeck. And whenever a train is shipped, all the tickets inside of Jira, so Jira is the tool that is used for the project management. We have a script that will go into Jira and tag all the tickets that need validation. So the client is informed of what has arrived on the validation environment. And now, for the most important part, we use the error collection tool called Sentry, and the collector, which is called Raven. So we have Raven Python, but we also use Raven GS. And here the idea is that the developer can ship with ease because he knows that whenever it arrives in the integration and the acceptance environment, the errors that are different because the data is different in production or different in acceptance will be collected as soon as possible by Sentry. And so we can iterate really quickly. So ship it, it breaks, we ship it again to fix it. One of the other things that we think is important is basing our having an intelligence in the metrics that we collect. So we have custom metrics and system metrics and performance metrics that are collected using Python tools. So the idea is to ship often, and whenever we see that the performance is decreasing, we go and fix that problem. So here to collect the metrics, we use Carbon and Graphite API. So Graphite is a way of serving the data. If you want a more detailed view about this, I've talked about this at Config Management Camp. We use SaltStack also quite extensively for that part. Having a continuous deployment requires also to have an agile infrastructure. So here we use SaltStack to have infrastructure as code. So deploying multiple environments is easy because of the definition that is stored in SaltStack. We use SaltCloud for portable cloud scaling, so we can reproduce an environment on our internal OpenStack. So the in-house hosting can be done, but we also are on AWS. The client chose AWS, so we were kind of portable with that. And on the supervision and metrics side of the infrastructure itself, we use Sensu, which again is not Python, but to pilot and configure Sensu, we use SaltStack, which enables us to deploy easily new checks and new metrics, and checks can be defined by the developers, which is, I think, a step forward towards the DevOps kind of paradigm. Net data is used for supervision, where part of it is in Python. There's a whole plugin Python ecosystem in net data. Test infra is a library that builds upon PyTest to test out some complex scenarios. So that's also included in our supervision, where we'll be able to describe scenarios such as put a file on that server and see if it appears on the other one, and that kind of stuff. Dashboards are very important in this kind of process. So the developers need dashboards so that they can see what is green, what is not, and where to focus their attention. So we ship often, and we should have notifications. So for that, we extract data from Jira, we extract data from Rundeck, and we build with badges because badges are cool. And for dashboards on the infrastructure side of things, we have Grafana with serving data from Graphite. So a little bit about the project impacts in terms of organization. Shorter tickets, so we split them into tiny chunks so we can ship often in small pieces. So that's one of the challenges. Sometimes it's hard to split tickets into small chunks. We have to work with the users to say that some environments and the validation environment in particular can be unstable, and that's a kind of, it's not a feature, but it's we have to get them used to saying if we want to ship often and you can see the demo and modify as we go, it can't be that stable. We try to make it stable, but it's not a feature of that environment. We have feature flags to encourage early integration of code, more peer review. Sorry, time's up. More peer review and collective appropriation through peer review. Normal semantic versioning, I talked about this. The future will be for another talk because I'm out of time. If you want to come work with us on these kind of issues, we're hiring, so come work with us, it's nice. And maybe no time for questions or questions outside. Sorry about, thank you.